Hello and welcome to Lecture 6 for Unit 2 for Intro to Logic. Today we're learning about some ways of getting yourself unstuck if you get stuck in a problem. So last time we looked at this chart, and this chart is my advice of what to do for different kinds of show lines. If you're trying to show an atomic statement or disjunction, do it by indirect derivation, conditional by conditional derivation, and so on. If you follow this chart and you apply the out rule to every line you get, you will get a contradiction. You will be able to complete that indirect derivation that you always end up doing. But there are certain circumstances in which it's not that easy to apply the out rule, and that's when there's an arrow statement or an or statement that you want to use, but you don't have the other thing you need to be able to use it. And when you do that, there's a technique that you use to get yourself unstuck that I'm going to call desperate measures. I'm going to skip some text here. This is just stuff that I'm going to cover when we actually look at the problem. But let's look at this problem here. We started by looking at the chart to see what kind of derivation to do for an or statement. For an or statement, it says do it by indirect derivation. We're going to assume the negation of the or statement. Use show line to show a contradiction. Now we can do certain things. We can break up the and statement at line 2. Get P on one line, Q on another line. We can apply the negation rule to line 4. We get the negation of each of the two halves. If an or statement is false, both halves are false. That's not wedge out. So we get R is false, we get S is false. When we get to this stage in the problem, however, there's not really anything to do. The problem is we need to use line 1, but the main operator of line 1 is this wedge. If we want to use it, we need to use wedge out. We need a rule, and to use the wedge out rule, you need the negation of one of the two halves of the or statement. We don't have that. We're stuck in this problem until we have the negation of one of the two halves of 1. So you get stuck in a problem, usually it's an or statement or an arrow statement that you want to use, but you don't have the other thing you need to use it. Remember that you can put in a show line whenever you want. We can show the negation of one of the two sides of 1. We could show not if P then R. If we can show not if P then R, we will have what we need to use line 1. But we need to actually show it. Now we can show whatever we want. It's negation. I'll show this by another indirect derivation. Assume if P then R, show that leads to a contradiction. When we have P at line 6, so we get R right away. From 6 and 11, arrow out. That gives us our contradiction. We have a contradiction between 8 and 13. So now we've shown this splat. We've shown this by indirect derivation. We still haven't shown this splat up at line 5 because we need to get that inside the actual box for that show splat, not inside another box. Once you draw a box around something, it's gone. But now that the word show is crossed off at line 10, I can use line 10. Remember, the point of line 10 was that I wanted to be able to use line 1, but I didn't have what I needed to be able to use line 1. Now that I have line 10, I can use line 1. I get if Q then S, that's the other side of line 1, from 1 and 10, wedge out. Then I get S from line 7. And I have a contradiction between 16 and 9. Now I've shown this splat, and therefore I've shown this by indirect derivation. So remember, when you get stuck in a problem, you can put in a show line whatever you want. Sometimes for an or statement or an arrow statement, you need to show the other thing you need to be able to do the wedge out or the arrow out. So put in a show line to show that, and once you show it, you can unstick yourself from the problem and complete the problem. So let's do another one that requires something like that. So this one, if you follow the chart, you do it by conditional derivation. We're going to assume not B, show not A. Now we have another show line. How do we want to show the new show line? Well, if you follow the chart, since we're showing negation, we do it by indirect derivation. Assume A, show a contradiction. Well, what do I do in this problem? The lines I can work with are 1, 3, and 5. There's nothing to do with a simple statement or its negation like 3 and 5. I need to be able to use line 1. But I can't use line 1 until I have one of the two sides of 1. That is, I need to either get to do the most ponens, either get the left part, or I need to get the negation of the then part to do the most tolens. I don't have either of those. So what I'm going to do is I'm going to put in a show line to show one of those, show D or not D. If I can show D or not D, then I'll be able to use line 1. If I can show D or not D wherever I want, I'll show it by indirect derivation. Assume not D or not D. Show a contradiction. So from the negation of an OR statement, you get each of the two halves being false. So we get not D, 8 not wedge out, and we get not D from 8 not wedge out. Both of the two sides, this side and this side of the OR statement, are both false if the OR statement is false. Those two lines contradict each other, so we get splat, 10, 11 splat in. Therefore, I've shown this by indirect derivation. Now that I have that, I can use line 1 and get if A then B. So put in the show line, line 7, so we'd have what we need to use line 1. Now we have what we need to use line 1. So I can use line 1 and get if A then B. Then I get B from 5 and 13. Arrow out. And the B and the not B contradict each other. So 3 now I've shown everything. Okay, let's do one more. So we're trying to show not P or Q. We're trying to show an OR statement, do it by indirect derivation. Assume the negation of the OR statement. Negation of the whole OR statement with the negation there. Show a contradiction. So if negation of an OR statement, you get the negation of both halves. So we get the negation of not P. Get the negation of Q. The same rule. Now if I want, I could take out that double negative on 5. But once I get to this stage of the problem, there's nothing to do until I can use line 1. I need to be able to use line 1. To be able to use line 1, I need the negation of one of the two sides. So I'm going to get the negation of the first half of 1 with a show line. I'm putting a show line to show not if P then Q. I can show that by indirect derivation. Assume if P then Q, show a contradiction. So I P at line 7, so I get Q from 7 and 9. We could also do the modus tollens, that's fine. But I did the modus ponens. Splat between 6 and 11. So I've shown that, therefore I've shown that by indirect derivation. Now I have what I need to use line 1. And I get R if and only if not R. From 1 and 8, wedge out. Uh-oh. I need to get a contradiction. Now 13 is a self-contradiction in the truth table sense. But to get splat, I need R on one line, not R on another line. How am I going to get that? Well, I can break up the biconditional into the two conditionals. The problem is I don't have R and I don't have not R, so I can't do modus ponens or modus tollens on 15 or 14 or 15. So until I get one of those, I'm again stuck in the problem. So once again, I'm going to put in a show line to give myself what I need. If I could show R, I'd have what I need to use line 14. So I'm going to show R, and I can show it however I want. I'll show it by indirect derivation. Assume not R. Show a contradiction. So if not R, then R, line 15, I get R. 15 and 17 arrow out. That gives me a contradiction between 17 and 19. So I've shown splat again, therefore I've shown R. Remember the point of showing R was that then I'd have when I need to use line 14. Now I have when I need to use line 14, so I get not R. From 14 and 16, I can use line 16 now that the show is crossed off. Arrow ought to get not R. So now I have another contradiction between 16 and 21. Finally, I've shown this splat, and therefore I've shown this. Okay? So when you get stuck in a problem, look for an or statement or an arrow statement that you want to be able to use but can't because you don't have the other thing you need to use it. Then put in a show line to show the thing you would need to be able to use it. Then once you show it, you'll be able to use that line and unstick yourself in the problem. I call that desperate measures. All right, that's it for today.